and welcome to Mrs. Riley's Maths videos. Today we're looking at something from statistics, which is one of the ways of representing data called a histogram. It's very similar in look to a bar chart, especially in junior cert and leaving cert ordinary level maths. It looks just like a bar chart except for a couple of crucial differences which we'll talk about now. But it's a way of representing data. So it's a picture of data to help us to understand what's going on with the data. Okay, so what we're going to look at today is we're going to look at what's a histogram, how do we interpret a histogram, how do I draw a histogram, and the advantages of histograms as a way of representing data. And that's what we'll get through now. Hopefully it won't be a very long video, and hopefully it'll be useful to you. So the first thing is that a histogram is like a bar chart with a few key differences. So it's like a bar chart, but it's got a few key differences. The first one is that it's used for continuous data. So for numerical continuous data. So that's things like where you could have any value, say between 0 and 10. So any value in a certain range. Whereas a bar chart is used for discrete data, like how many pencils in your pencil case. This would be how long is your pencil case, would be the numerical continuous data. How long is your pencil case is this. So how long is your pencil case? Could be any value within a certain range. This would be how many pencils in your pencil case. Okay, so that's the difference between numerical discrete and numerical continuous. This is only whole numbers. I suppose you could have half a pencil, but we won't count that. Okay, so you use a histogram for continuous data. It's like a bar chart in that it's bars, but because it's continuous data and because it's used for grouped frequency tables, which we'll look at in a minute, grouped frequency table. Because it's used for a grouped frequency table, the bars are joined together, as it were. Bars are side by side with no gap. Side by side, no gap between them. And we'll see what that looks like. So a bar chart would look something like this. That's a bar chart. Whereas a histogram would look something like this. That's a histogram. Okay, so there's no gaps in a histogram because the data is grouped and it's continuous numerical. There are gaps in a bar chart because it's discrete data. And then in your course, and for the sake of your course, we'll look at the height. In any histogram, really, it's the area of the bar that shows the frequency. Now the weird thing is that in your course we only ever do bars of the same width, but normally the bars could vary in size, and when we have that happening, then it's the area of the bar. So in a normal histogram outside of your course, you might get something like this, where the bars are different widths. Okay, and it's the area of the bar that shows the frequency. For the sake of your course, all the bars in junior cert and leaving cert bars are all the same width. So the height will be proportionate to the area. So the height and the area both show the frequency. Okay. Okay, so bar charts. The bars are separated. They're used for discrete data. It's the height of the bar that shows the frequency. A histogram, the bars are side by side with no gaps. It's used for continuous data, continuous numerical data from a grouped frequency table, and it's the area of the bar that shows the frequency. In your case, because the bars are all the same width, actually it's still the height that shows the frequency. Okay, so that's what a histogram is. Let's look at an example here. So let me just get this. So here is an example that we're going to look through here, just to show you this is what a grouped frequency table is, remember? Grouped frequency table, where you're going from 0 to 10, 10 to 20, 20 to 30. It's continuous data. You could be any age between 0 and over here is 80. That's continuous data. Okay, that's a grouped frequency table, which is what we use for histograms. Here's a histogram here. Let's interpret this one. So in this one, the histogram below shows the results obtained by a group of students in a maths exam. How many students are represented in this histogram? How many students got between 40% and 80%? What percentage of students failed this exam? What are the maximum and minimum number of students who could have gotten greater than or equal to 70%? How can you suggest a way in which this histogram could be changed to provide more information? Okay, so let's talk this through. How many students are represented in this histogram? Well, let's look at this histogram. Here we have a scale going along the upright, which is our frequency scale. So this is how many students. Okay, percentage in maths exam, this is what we're counting. So this is the score, this would be the X and this would be the F. Here it's the score between 0 and 100%. A student could get any score between 0 and 100%. If you notice here, we've got the bars are all the same width, like we said they would be, and there's no gap between the bars, whereas in a bar chart there would be a gap. So our frequency distribution table would be a grouped frequency distribution table, where it'd be 0 to 20, 20 to 40, 40 to 60, 60 to 80, and so on. If you notice the numbers on our percentages here, on our scores, we don't put them underneath like we would in a bar chart, so we'd put it here or here. What we do is we put it at the start, and then we do our scale evenly all the way along the x-axis, and we just put our bar between the numbers either side of our group, and we'll see that in a minute when we come to draw it. So looking at this, our scale here goes from 0 to 50, and it looks like each of these lines, well, there's 5 lines and then it's 10, so there's 2 people for every line, that dotted line that's drawn. So for this one here, this is obviously 4 people. This is 2, 4, 6, 8, 9 people. This one up here is 20 people. You can see that, 20. This is up as far as 40 people. And this is up as far as 20, or is 22. Let's just see here. Well, there's 20, 22, 23 people. Okay. So how many students are represented? Would be 4 and 9 is 13, and 20 is 33, and 40 is 73, and 23 is 96 people. Seems a strange number of people to represent, but anyway, 96 people represented. Let's just check that. I don't think I got that right, did I? 4 and 9 is 13, and 20 is 33, and 23 is 56, and 40, yeah, 96. Okay. Okay, so 96 people, and what we've got here is that we're going to see now. Does that make sense? 4 people got between 0 and 20. Yes, that makes sense. Most people actually did well there, didn't they? They got between 60 and 80. So the modal group, if we were asked for that, would be between 60 and 80. How many students got between 40% and 80%? So here's our 40%, here's our 80%. Anybody that falls between these two is what we're counting. So 20 and 40 would be 60 people got between 40 and 80%. What percentage of students failed this exam given a pass is 40? So here's a pass of 40. 9 people got between 20 and 40, and 4 got between 0 and 20. So 13 people got failed the exam. If I had to work that out, that would of course be 13 over 96 times 100. Okay. What are the maximum and minimum number of students who could have gotten greater than or equal to 70%? So we had a question like this before in our grouped frequency distribution table. What are the maximum and minimum number of students who could have gotten greater than or equal to 70%? So here's 70% here, isn't it? Here's 70%. So if we think about it, the maximum number would be if all of these 40 people all got more than 70 plus these 23. So the maximum would be 63. The minimum would be if none of these people got above 70, if they all got between 60 and 70. So none of that 40 got over 70. So only these people got over 70. So that would be 23. Can you suggest a way in which this histogram could be changed to provide more information? Well, I suppose what we could do is we could make the bars narrower. So we could have 0 to 10, 10 to 20, 20 to 30, 30 to 40, and so on. That might be helpful. Okay, that's what a histogram looks like and how we'd interpret it. Let's draw one quickly. So here we have a grouped frequency table, and in this we have the speed of 100 cars passing a speed camera on a certain day. Okay, so here we have between 60 and 70 kilometers per hour, there were 15 cars, between 70 and 80 there were 19, and so on. And if you notice, we're told in a note, like there should be a note on all group frequency tables saying 60 to 70 means they were going any speed between 60 all the way up to 70, but not quite 70. Okay, so what we're going to do here, hopefully I've got enough room, we draw our axes. So here is my horizontal axis, and there's my vertical axis. I've got to go up as far as 33. So what I'm going to do is I'm going to go up in, I don't quite have room to go up in 5, so I'm going to go up in 4s. So 1, 2, 3, 4. So that's 10. 1, 2, 3, 4, 20. 1, 2, 3, 4, 30. Actually, that's, yeah, we'll do that. Okay, we'll just, at the top, we'll just be careful how we draw 33. So here along the bottom, now notice we don't have to go all the way down to 0, so I'm going to put 60 here, and then I'm going to go along in 4s as well. 60. I don't have to do the same scale along the bottom. 80, 90, 100, and 110. Okay, this is speed of cars. So it's very important when we draw a picture, a statistical picture, that we label it, and this is the number of cars. And we should really put in here kilometers per hour. Okay, so here we draw our histogram. 15 people went between 60 and 70. So 15 people is here. Maybe I'll just put in, that's 5, that's 15, that's 25, that's 30, and that's 35. Okay, 60 to 70 is 15 people, so I'm going to draw up here a line to 15 and across. 70 to 80 is 19 people, so it's just going to be just under there, isn't it? So just under 20. And a line down. 25 people is here. And down. 90 to 100 is 33 people, which was this one that's going to get me into trouble up here. Should have checked that, but anyway, listen, let's just keep going. And 100 to 110 is 8 people, so that's 7.5 there, so 8 is just above it. Okay, and there's my histogram. Okay, as you see, it looks like a bar chart, except the bars are side by side, and you can see though that the heights of the bars do reflect the differences in the frequency. Remember, this is your frequency and this is your X, what you're counting. Okay, so just very quickly, one last thing that a histogram is useful for, and that's for showing the distribution of data. This isn't something we talk about too much in junior cert, but we do talk about it in leaving cert a lot, so I'm just going to mention it to you now. So when you're drawing a histogram, okay, and here's some histograms that they've drawn. Okay, so what they're saying here is that here you can see in a histogram, you can see that actually every group was equally represented. These are the scores, 20 to 30, 30 to 40, and so on, but the data is evenly distributed all the way across. Okay, here you can see this kind of looks what's called a bell-shaped curve, or a bell-shaped distribution, or a normal distribution. And this is what you would expect to see, say if you'd set a good test for a class and these were the scores they got, you'd expect that if you're to draw a histogram, or later on we'll see a stem and leaf, or some kind of cumulative, some kind of frequency curve, you'd expect to see this shape. Okay, and what it is, it's called a normal distribution, if you've heard of that. And what it shows us is that most people got around the middle value, which is also the mode, which is also the median, and which is also the mean. Okay, that's a normal distribution. Okay, this one here if you can see, actually in this test it was probably too easy, because in this test more people got a high score whereas very few people got a low score. And this type of distribution is called a negative skewed distribution, negative skewed, or a skewed left. Now it's funny when we're talking about skewed is kind of not normal shaped. Skewed means it's kind of off to one side. When we talk about skewed left or skewed right, it's this tail that we're talking about. So this is a skewed left distribution, or a negatively skewed distribution, and here is a skewed right distribution. Okay, again, most of it is probably too hard a test. Most people only got between 40 and 50%, whereas we would have preferred to have more people getting in the middle, like in a normal distribution. It was probably a bit hard. Lots of people failed and very few people scored up high. Okay, so that's called distribution shape, and distribution is something that a histogram does give us a clear picture of. Okay, talk to you soon. Thanks.